Statistics. Statistics helps make sense of the data collected. Statistics helps describe data like the central tendency and dispersion of the data. Statistics also helps with testing a hypothesis. In addition, statistics helps with building mathematical models, like those used in self-driving cars. Data types. Variables can either be discrete or continuous. For example, a type of fruit is a discrete variable. Often, discrete variables are either true or false. Here are some examples of discrete clinical variables. Continuous variables can take on a range of values. Height is an example of a continuous variable. Here are some examples of continuous clinical variables. Statistics help describe data using normal distributions. The distance between two samples of data can be measured using the standard deviation. The further apart the data, the more different the data is. The null hypothesis, or H0, states that there is no difference between samples of data. With discrete variables, that means the ratio between both samples is 1. For example, the mortality across groups is the same. With continuous variables, the difference between both samples is 0. For example, the systolic blood pressure across groups is the same. We then measure how far away the trial data, or H1, is from H0. Generally in medicine, if the data in H1 is more than 2 standard deviations away from the data in H0, then it is sufficiently different to reject the null hypothesis. 2 standard deviations, 95% confidence interval, and p-value less than 0.05 are all acceptable measures of distance between H0 and H1 in biomedical research. In diagnostic tests, choosing a threshold means making a trade-off between sensitivity and specificity. For example, moving the threshold to the right increases specificity and decreases sensitivity. Most of the time, however, both sensitivity and specificity are important and can be expressed using one statistic known as the area under the ROC curve. A perfectly accurate test has an area of 1. Confidence intervals give us information about the statistical significance and clinical significance. Confidence intervals are used to measure distance from the null hypothesis. When the confidence interval overlaps a ratio of 1 or a difference of 0, the result is said to be statistically insignificant. Confidence intervals help clinicians decide on clinical significance. For example, a statistically significant result that is really close to the null hypothesis may be clinically insignificant. Your patient likely falls somewhere in the range of values in the confidence interval, and you have to determine if your intervention will make a clinically significant benefit to their health.